All right, again, so this is section 7.8. There's a couple reminders up at the top. The first one there is if you multiply with like bases, you have to, turn around please.
Oh, okay.
You have to add the powers on, all right? And then the other part of this, it says basically you're going to multiply the numbers together, and then you're going to multiply the variables together. Now remember, you can multiply in any order, right? So if you look at that first problem, so again, that was basically it for the notes. I'm just going to do the examples. So if you look at that first example right there, you can multiply in any order you want. So, for example, there's a multiplication between the 6 and the y cubed. There's another one between these two monomials. There's also another multiplication between the 3 and the y to the 5th. So what we can do is we can multiply in any order we want since it's all multiplication. So what we're going to do then, I won't do this on all of them, but I'll show you on this one. We're going to do the 6 times the 3. And then we're going to do the y cubed times the y to the 5th. So what's 6 times 3? Is 18. And then you've got like bases, so you end up adding the powers, so you get y to the what? Good. Yep. So it's y to the 3 plus 5 power. And that's it for the first one. So like I said, we have quite a few examples, but they're not that long. So let's look at number 2. Now I'm not going to rewrite it like I did on the last one, but basically we're going to do the 3 times the 9 first. So what's that? 27. So we got 27. And then we're going to do the, let's see, we'll do the m. Well, that m has a first power on it, right? So we're going to do the m times the m squared. So that's going to give us m to the what?
Third.
Good. So we're going to get an m to the third. And then we're going to multiply the n squared. Again, that's an n to the first right here. So n squared times n to the first. That's n to the what? I guess that power didn't show up very good on there. That's the n to the first right there. So what's n squared times n? N to the what? Got to add the powers. There you go. Yep. So you got to add the power, so that would be a 3 also. And then that's it for that one. So let's go to number 3. So on number 3, you'd have a 1 right here in front of that ST. But really, you're just going to multiply the, you're going to multiply the 1/4 times the negative 12. So multiplying by 1/4 is the same thing as dividing by 4. So what's negative 12 divided by 4? What's that? Yeah, negative 3, good. So you got a negative 3. And then you're going to do the, you got a s squared times s to the first, and then times another s to the first. So you end up with s to what power? Yep. Yep. You add the power, so it's 2 plus 1 plus 1, so that's the 4th power. And then you got a t. So that's going to be t. And then you've got a t to the first right here in the middle. So you got t squared times t to the first times t squared. So you get t to the what? Again, you got t squared times a t to the first times a t squared. So add the powers, you get what? Good, yeah. Be the 5th power. The powers, if you add them, you'd have 2 plus 1 plus 2. So that's it for that one. You guys good so far? Peter, you good? Excellent. All right. Now when you go to number 4, now notice this is not all multiplication. You have an addition right here, and you have a subtraction. So what this one is this is just the distributive property. All right, you have a multiplication right there, if you can see. So you got to distribute the 4. So you're going to do the 4 times the first term, and times the second term, and times the third term. So you're going to do 4 times 3. What's that? That's a 12. Oops. So that is a 12x squared. Then you're going to do the positive 4 times a positive 4x. 16 what? Yep, that's a positive 16x. And then you're going to do the positive 4 times the negative 8.
Minus 32.
Yep. It's a negative 32, so you write minus 32. And there you go, that's that one. And that's already in standard form right there. It's in descending powers of x, and the leading coefficient will be a 12. Let me see if I can go out here and gather up some phones. Thank you, buddy. Yours disappeared too, that's good. It's going in the phone cell. Aiden, did you see? Look how sad it is.
It is very sad. So I should be
All right, number 5. So 5, same thing. We've got this one term out in front, right? The term we got out in front is 6 times a P times a Q. All right? You got to distribute that. So really what you're going to distribute is this whole thing here, this whole monomial. So you're going to distribute this onto the 2P and onto the negative Q. So what's 6 times 2? That's 12. And then you got a P to the first times a P to the first. Good. Thank you, Tom. That's P squared. And then you got the Q still. All right. And then you got to do a positive 6 PQ times a negative Q. So that's going to be a positive times a negative. That's going to be a negative. Now really there's a 1 here. So it's really 6 times negative 1 is negative 6. So you write minus 6. And then you got a P to the first. And then you got a Q times a Q. There's a Q to the first right there times another Q to the first right there. So you get Q to the what? Second, good. And that's it for that one. Like I said, so there's quite a few examples here, but they go pretty quick, at least until the last couple. So let's look at 6. Again, we've got to distribute that whole monomial out in front of this thing. So we got to distribute this. There's a multiplication right here. So we got to distribute this whole thing onto the first term and onto the second term. So first of all, you got 1/2 times 6. So what's half of 6?
3.
That's 3. So you got a 3. And then you got an x. Well, you got an x squared times a x to the first. X to the third, good. And then you got a y. And that's going to be a y to the first times a y to the first. Y to the, yeah, y to the second. Again, you're just adding the power, so 1 plus 1 is 2. Noah, you got a phone for me there? You sure? Then you got, again, this is a positive 1/2 times a positive 8. So what's half of 8? That's going to be a positive 4. And then you've got an x squared times an x squared. So add the powers, you get what? 4th, good. And then you got a y to the first times a y to the second. Good. And that's it for that one. All right, so where are we at here? So that's it for that page. So turn the page. And there's quite a few of them on this page. Again, I don't think we're going to do them all, though. So it talks about right here, it says something about we are going to use the box method. Well, I'm not going to use the box method, okay? So I'm not doing that. So we'll strike that out. We're not going to do that. Which means we really don't need these two line segments they have drawn here. We don't really need them. I could have whited them out before I made the copies, but we still have enough room. But we are going to use this thing over here. We're going to multiply, and it says FOIL, FOIL. We are going to use that idea. But really how I want to do these, in fact, let's skip that first one there. Let's go down to number 7, so this one. Really how I want to do these is I want to do them with the distributive property twice. So what you end up doing on here, for example, you take the S and you distribute it. So the S gets distributed onto these two terms in the second binomial, and then the positive 4 gets distributed onto those same two terms in that second binomial, like that. So that's how I'm going to do these. All right? So let's do it. So in the blue there, we start out and we do S times S. What's that? That's S to the second power. So don't say S times S is not 2S, okay? That's if you're adding. S times S, anything times itself would be squared, so it's S squared. Then we're going to do the S times the negative 2. Yep, that's a negative 2S, so we write minus 2S. All right. Then in the red there, we're going to do the positive 4 times this S. What's that? Yep, plus 4S. Good. That's a positive 4S. And then finally, we'll do the positive 4 times the negative 2. That's a negative 8. So since it's a negative 8, we write minus 8. All right, now notice we can combine those two terms in the middle. Do you see that? You can only add or subtract if the variable part matches exactly, including the exponent, which it does in here, right? So what's 4 S's take away 2 S's?
2 S's.
That's a positive 2 S's. So we're going to have a positive 2S in the middle. And then we're going to bring down the minus 8 and the S squared out in front. And there you go. That's that one. Now, why do they call that FOIL? Well, it's because if you look what we did there, we multiplied the S times the S first. That's the first terms in each binomial. Then we did the outer terms. We did the S, that first S times the negative 2. That's the outer terms. Then we did the positive 4 times the S. That's the inner terms. And then we did the positive 4 times the negative 2, which is the last terms in each binomial. So that would be first, I went the wrong way. That would be first, outers, inners, last. So they call it FOIL. But really, it's just the distributive property twice. So let's do number 8. So number 8 is the same thing. You just got to remember that if something is squared, it means it's times itself, right? So this is really the quantity x minus 4 times the quantity x minus 4. That's what it means to square something, right? And then we're just going to do the same thing we did in the last one. So we're going to distribute this x onto both of these terms. And then we're going to distribute this negative 4 onto both of these terms. So really, it's just a distributive property twice. So in the blue, I got x times x. X squared. Yep, not 2x, it's x squared. And then we've got the x times the negative 4. What's that? x times negative 4. I hear it very
Negative 4x.
Yeah, negative 4x. It's a positive times a negative, so it's a negative 4x. So I write minus 4x. Remember that subtraction right there, that implies that that 4 is negative, okay? All right, then we got to do what we had in the red there. So in red, we've got the negative 4 times the x. What's that? You guys are quiet today. What's negative 4 times positive x? What's that?
Negative 4x.
Good, yeah, negative 4x. So we got a negative 4x. And then to finish it, we've got to do the negative 4 times the negative 4. Yep, good. That's a positive 16. So we write plus 16. All right, then notice again, we can combine the like terms in the middle. That's like what we were doing yesterday when we were adding the polynomials. So we got negative 4x's, take away 4 more x's. Negative 4, take away 4 more.
Negative 8x.
Yep, negative 8x. And we'll bring down the plus 16, and we'll bring down that x squared in the front. That's that one. All right, we'll do, I guess we'll do one more of these. We're getting there. We're already on 9, so. This one, again, we're going to distribute this 8m squared onto both of these terms. And then we're going to distribute the negative n onto both of these terms. All right, so the first here in blue, we got 8m squared times 1m squared. That's 8m to the what? 4th, good. Yeah, you got to add the powers. M squared times m squared is going to be m to the 4th. And then we got to do the 8m squared times the negative 3n. So we got to do the 8 times the negative 3. So what's that? Good. So that is a negative 24. So we write minus 24. And then we also got to do the m squared times the n. Well, that would just be an m squared n. All right. And then in the red, we've got to do a negative 1n times 1m squared. So negative 1n times a positive 1m squared. Well, it's definitely a negative times a positive, so that's going to be a negative. And then it's a n times a m squared. But that's the same thing as m squared times n. Usually you will put the letters in alphabetical order. So it'll be a negative 1 m squared n. And then finally, the last part, we got to do negative 1n times a negative 3n. So what's negative 1 times negative 3? Yep, it's a positive 3, so we write plus 3. And then we've got an n times an n. Good. Yeah, it's n to the first times n to the first. So it's n squared. And then you can see in the middle here, we have some like terms again. So we got negative 24 of those m squared n's, take away 1 more of them. So what's negative 24, take away 1?
Negative 25.
Yep. So we got negative 25 m squared n's. And then we got to bring down that plus 3n squared at the end there. And then out in front, we still have the 8m to the 4th. So that's that one.
No, it's a...
All right, so number 10. All right, there's 10. All right, so on 10, the only difference is we got a binomial times a trinomial. I think we'll do 10 and 11. We can skip 12 because basically it's the same thing. So we got a binomial times a trinomial. Ryan, you got a phone for me there? You don't?
No.
I think you do. So then we're still going to do the distributive property twice. So we're going to distribute this x onto all three terms on that trinomial. And then we're going to distribute the -5 onto all three terms. Like that. So we got to do 6 multiplications. So in the blue, we got x times x squared. Remember, that's x to the first right there. So what's x times x squared? Good, x to the third power. Thank you, Ryan. Then we got a x times a 4x. Good, that's a positive 4x squared. And then we got a positive x times a -6.
Minus 6x.
Good, it's a -6x, so we write minus 6x. Then in the red, we've got to do a -5 times x squared. So right here, -5 times x squared. What's that? Good, -5x squared. Now I could write that right here, but I think I want to write it right here because I know that then I have like terms that I can combine. So I'm going to write the -5x squared below the positive 4x squared. Then I've got to do the -5 times the positive 4x. So what's -5 times positive 4? Yep, so that gives me a -20x. So I'm going to write that right below here like this, -20x. And then to finish it up, I have to do the -5 times the -6. It's a positive 30, so I'm going to write plus 30 right here. All right, well now I'm set up where I can combine like terms, so what I'm going to do here is I'm going to add these together, okay? So when I add them together, I got x cubed. Then I got 4x squared, take away 5x squared. What's 4 take away 5?
Minus 5.
Yeah, it's a -1x squared. Or you can just write -x squared. Then I've got -6x's, take away 20 more x's. Positive or negative? Negative, yep, so it's a -26x. And then I bring down the plus 30. And that's it for that one. One more of those? Or do you think you're good on that part? You good with that?
Yeah, I'm good.
Let me see if there's anything weird on that one. Let's see, you get that. All right, yeah, I'll leave that one off. Let's go to the word problem then. So we're going to go to the word problem. The story problem. First of all, the story problem's messed up here. Whoever made this thing messed it up. It says the width of a rectangular prism is 3 less than the height. The length of the prism is 4 more than the height. And then it says write a polynomial to represent the area. Well, no, this should say write a polynomial that represents cross this out. That represents the volume. Because a rectangular prism is like a box. I'll draw it for you on the side over here. So what we're really looking at is something like this. We've got like something like this. And then it would go like and then like this, that, like that, like that. That's a rectangular prism. It's like a box. All right, now let's see if we can do the problem. So the first thing we got to look at here is it says, what does it say? It says the width is, so that would say W is, so W equals. It says it's 3 less than the height. So that would be 3 less than the height. So that would look like that. And then the second part of it here, it says the length. So there's the length is, that's 4 feet more than the height. So the length is, how do I write 4 feet more than the height?
H plus 4.
Good. That'd be the height plus 4. That's 4 feet more than the height. All right, so now I can go label my picture. So what my picture should look like then is, if I can keep all this on here at the same time, maybe I can't. This is going to be the height right here. Then the width is going to be the height minus 3. And then the length is going to be the height plus 4. Like that. I'll zoom in on that so you guys can see. Again, this side over here, or that dimension, that's the width. This h plus 4, that's the length. So then where they messed this up is they gave that formula for the area was length times width. No, we want to find the volume. So what we want to do is we want to do the volume is equal to the length times the width times the height, like that. So if we set that up instead, let's see, so the volume is going to equal the length, which was, I don't know, h plus 4, times the width, which was h minus 3, times the height. So what, do you guys see what I did there? I just did length times width times height, based on that picture right there. All right, then we just gotta multiply that all out, and then we got the answer for part A. So what you should do here is you should distribute this h. So even though I got it written backwards, you can see I can distribute it like that. There's a multiplication right here. I don't have to have the h in front of that quantity, h minus 3 in the parentheses. I can have it behind it like that. In fact, watch for that on the SAT, because they like to do that kind of stuff all the time just to confuse you guys. So we're still gonna do the h times the h, which is going to give us a h squared. And then we're going to do the h times the negative 3, which is going to give us a negative 3h. And then we still got to multiply that by that h plus 4 in the front. And that's going to equal the volume. All right, and then now this is just like we were doing on all the rest of the problems. So we're going to have to distribute this h onto both of these terms. And then we're going to have to distribute that positive 4 onto both of these terms. So then in the black there, we got, I wanted black. In the black, we have h times h squared. Good. And then we got a h times a negative 3h. And again, that's a 1h right here. So what's h times negative 3h? Negative 3h what? Yep. So it's a negative 3h squared. And then in the blue, we got a positive 4 times an h squared. So what's that? Positive 4 times positive h squared. Again, there's a 1 right here. Come on, guys. Positive 4 times h squared. Just positive 4 times h squared.
4h.
Yeah, it's 4h squared. Or positive 4h squared. And then we got a positive 4 times a negative 3h. So again, I'm doing this part right here. I'm doing positive 4 times the negative 3h. Yep, negative 12h. So that is negative 12h. And then like just like on all the other problems, I got to combine like terms in the middle right here. So what's 4h squared? Take away 3h squared.
1h squared.
That's 1h squared. That'd be a positive 1, right? And then I got that h cubed out in the front still. And I got the minus 12h at the end. And then that's equal to my volume. So all of that is the answer to part A. All right? Part A said write a polynomial that represents the volume. So that whole thing right there, I'll put part A right there. So that's the answer to part A. And then in part B, it says, what is the area? Well, again, that's an error. That should say, what is the volume? So that should say volume right there. It's kind of unlegible. Volume. So what is the volume if the height is 5? So the height is going to equal 5. So what do I do with that? That's what that's telling you right there. What am I going to do with the 5? Plug it in. Yeah, I'm going to plug it in for h. So I'll kind of keep this where you can see both of these. So we're going to take h equals 5. So we're going to take the 5. We're going to take 5 for h, and we're going to plug it in right there, and right there, and right there. So if we do that, we would get the volume is 5 to the third power plus 5 to the second power minus 12 times 5. So I just replaced the h in my volume formula with the 5. All right, so then, let me slide this down. So what's 5 cubed?
25. Or no,
125. Almost done. Plus what's 5 squared? 25. And then minus 12 times 5.
Negative 60.
Good. So if we get a final volume of 125 plus 25 is 150. 150 minus 60 is?
90.
It's 90. Now the units on this was in feet, right? The height was in feet? Yes. Because when you do the length times the width times the height, you'd have feet times feet times feet, which would give you cubic feet. If you do area, it would be feet to the second power, that's square feet. But when you do volume, it's feet to the third power, which is cubic feet. And what that means, I mean, that's your answer for part B right there. So there's part B. What that means is 90 cubic feet would fit inside of your box here, into this thing. Okay? So if I draw you a cubic foot would be like, it'd be like this. This would be your cubic foot. And your cubic foot, the dimensions of it would be it'd be 1 by 1 by 1, all right? The width would be 1 foot. The width would be 1 foot. The length would be 1 foot. And the height would be 1 foot. Just getting you guys ready for geometry. So that would be 1 cubic foot if it has dimensions 1 by 1 by 1. And then 90 of those would fit inside of this thing. That's what your volume means. So when you got that answer of 90 cubic feet right here, 90 of these little 1 cubic foot boxes would fit inside of this thing and fill it up completely. All right, so that's it for 7-8.